In Lab 3, you controlled the speed of a motor with a potentiometer and the Arduino. In Lab 4, we want to add a feedback control system to your motor driver. And feedback control is one of the foundational parts of electrical engineering. It's the reason that rockets go straight up. It's the reason that if you have a CD player, the motor turns at a constant rate. The way we keep the world running like we want it to is feedback control. And we're going to do a simple version of it, but let's cast it in the language of controls so that you understand how what you're doing fits into that larger picture. So a typical feedback control system would look something like this. Maybe we have a motor, and we're going to put some gas into the motor, and that motor is then going to go at a certain speed. Now, and I've left a hole here for something coming in a minute. Normally, you could be driving down the road and you put your foot on the pedal and that controls the speed. But you're on a long journey, you want to use a system to keep the motor going at a certain speed, keep the car going at a certain speed. So what we could put here is some sort of sensor. This would read the speed and allow you to, and that would be like the sensors that we use in this class. Then maybe I would do some sort of calculation, some conditioning of that signal. Let's just say a compare. And what I mean by that is if the speed is larger than I want to be going, or smaller, this is going to send another signal out, and I'm going to use that to add or subtract to the amount of gas going into the motor. So let's imagine that I've got gas going into the motor, and I'm going at 53 miles an hour, and I want to be going 55. So I measure 53 miles an hour, I compare that to 55, I come up with a negative number, and so I decrease the amount of, increase the amount of gas, and I use that now. The speed should come up. As the speed comes up, maybe it goes past 55, and maybe it gets to 60 miles an hour. I once again compare, and I say, oh, 60 is bigger than 55. I need to decrease the amount of gas, and so I'll send a negative signal, I'll decrease the amount of gas, and I'll bring it back. That's the world's simplest control system, but it's got the general idea that we have an input to something we want to control. We measure the quantity that we'd like to control with some form of sensor. We take that data, we do some sort of processing on that signal to decide how to change the input and send it back to the thing we're trying to control. So we're going to do much the same thing in this class, but a little bit simpler. So let's look at how you're going to put feedback control into your motor system. The thing we're actually going to control here is the motor driver. We're not actually looking at the motor, we're looking at the motor driver. That's that chip, that board you have. And what comes out of the motor driver is the current that eventually goes off to run the motor, out of which maybe there's some speed. We're going to put here the current sensor. And what's going in over here is the signal from the power supply, the actual power that we're putting into the motor driver. And you can think about that as voltage or current or whatever you'd like, but this is what we're providing to the motor driver so it can send some current off to the motor. So once again, you're going to put some conditioning here. Maybe you'll just call that a compare again. Is the current higher than I'd like it to be? And we're going to do the simplest form of control there is. We're going to put our relay here. So I'll just make that a box. with a switch in it, and here's the control line, and I'll call that a relay. So now how is this going to work? We're going to turn on our system. Presumably the relay would normally be closed. That's going to turn on the motor driver, which is going to send some current through the current sensor off to the motor, and the motor's going to turn. And generally, everything would just be happy. Then maybe you reach over here and you grab that spindle, and you really make that motor start having to work hard. When you do that, it's going to draw more current from the motor driver, and you're going to detect that in your circuit as an increase in the current drawn. And your software is going to look at that value and at some point say, oh, that just passed 1 amp, and I think that's too much. I don't want to burn out my motor by letting the current go higher than that. And so when that signal passes 1 amp, you will send a signal to the relay and you'll open the switch. You might then, here, have a timer, and you might say, I'll wait for 5 seconds, and then I'll close it again. In other words, you can put a fair amount of sophistication here. You might say, oh, if you grab the spindle here and you don't let the motor turn, and the current goes too high, I'm going to measure that, but I'm going to measure that and wait for a certain amount of time. I'm not concerned about instantaneous spikes of the current, but if it goes 5 seconds above an amp, perhaps, oh, now I'm concerned, and I'll send the signal out. So the point is, you can put a fair amount of sophistication here. This is where you make the decision of what signal you're sending back to the input to control the system to get the desired output that you want. So ours is very simple, bang, bang, just turn it off, turn it on and off. But the basic idea of using a sensor, conditioning and deciding and manipulating that signal to make decisions, and then sending some signal back to the beginning of the system in order to control the whole thing is fundamental and something you could very much do in your final projects.